There is a liquid that costs less than $2 at any grocery store and transforms dead, compacted soil into a thriving, living ecosystem within just 72 hours. Not a chemical fertilizer manufactured in massive industrial facilities using fossil fuels and toxic processes. Not an organic amendment sold at premium prices with fancy packaging in upscale garden centers. Not a complex proprietary formula developed by agricultural scientists in corporate laboratories and marketed through expensive distribution networks with celebrity endorsements. A simple liquid that has existed for centuries in kitchens and farms worldwide. Available on the shelf of every grocery store on the planet that the $70 billion global fertilizer industry desperately prays home gardeners never discover. Pour this liquid onto dead, compacted soil where nothing has grown for years. Within 3 days, earthworms appear by the hundreds, seemingly from nowhere. Within a single week, the soil structure begins changing visibly right before your eyes. Within a month, ground that was lifeless and hard as concrete transforms into dark, crumbly earth. Absolutely teeming with biological activity and fertility, the liquid feeds soil bacteria that have been starving in chemically treated ground. The bacteria multiply explosively when given what they need. The bacterial bloom becomes food for protozoa and nematodes. The protozoa become food for earthworms that tunnel upward from deeper soil layers following the biological feast. The worms are not planted or introduced. They already exist deep in the ground where soil biology barely survives. They migrate toward the food source that suddenly appears in upper soil layers. They arrive by the thousands because the signal of bacterial activity spreads through soil faster than most gardeners realize. Fertilizer companies have known about this liquid for decades. Their own soil scientists understand exactly how it works. They have deliberately chosen not to educate consumers because educated consumers stop purchasing fertilizer. A gardener who understands soil biology needs nothing the fertilizer industry sells. This liquid is blackstrap molasses, the final byproduct of sugar refining that costs pennies per application and outperforms products costing 50 times more. The soil amendment that the industry built on dead soil chemistry desperately hopes remains obscure. In the next 14 minutes, everything the fertilizer industry has hidden. The exact science of how molasses revives soil biology, the application rates that maximize results, the comparison that humiliates synthetic fertilizers on every metric, and the economic threat that explains why $70 billion of annual revenue depends on your ignorance. One liquid, 3 days, thousands of worms, the file is open. There is a biological process that explains exactly why molasses brings dead soil back to life. Healthy soil contains billions of microorganisms per tablespoon. Bacteria, fungi, protozoa, and nematodes form complex food webs that cycle nutrients, create soil structure, and support plant growth. This biology is the actual engine of soil fertility. Plants evolved over hundreds of millions of years to depend on these microbial partners. Synthetic fertilizers bypass soil biology entirely. They deliver nutrients directly to plant roots in chemical forms that require no microbial processing. The convenience comes with a devastating cost. Soil microorganisms starve when plants no longer need their services. The biology that took decades to develop dies within seasons of chemical application. The death spiral accelerates with each application. Fewer microorganisms means less nutrient cycling. Less nutrient cycling means greater dependence on synthetic inputs. Greater synthetic application means further biological death. The soil becomes an inert medium holding chemical nutrients rather than a living ecosystem generating fertility. Molasses reverses this death spiral by feeding the survivors blackstrap. Molasses contains approximately 55% sugar, primarily sucrose with glucose and fructose. These sugars are immediately available food for soil bacteria. A single application provides an energy source that bacteria have been starving for since chemical treatments began. The bacterial population explosion is measurable within hours. Researchers have documented thousand-fold increases in bacterial counts within 48 hours of molasses application. The soil that appeared dead was actually dormant, waiting for food that chemical agriculture stopped providing. Bacteria are not the end of the food chain. Protozoa consume bacteria. Nematodes consume protozoa and bacteria. Earthworms consume all of the above, plus organic matter that bacterial activity begins decomposing. Each level of the food web responds to abundance at the level below. The worms that appear within 3 days are responding to this cascade of biological activity. They detect the chemical signals of bacterial feeding and migrate toward the food source. The migration can cover several feet vertically as worms move from deeper soil layers where minimal biology survived toward the surface where the feast is occurring. There is a mineral content in blackstrap molasses that provides benefits beyond simple sugar feeding. Blackstrap molasses is the final extraction of sugar refining. The portion that remains after sucrose has been crystallized and removed multiple times. This concentration process leaves behind minerals that were present in the original sugarcane but not desired in refined white sugar. Iron content in blackstrap molasses reaches significant levels. A tablespoon contains approximately 20% of human daily requirements. This iron becomes available to soil microorganisms and eventually to plants through biological cycling. Iron deficiency that causes yellowing leaves often corrects within weeks of molasses application. Calcium content supports soil structure improvement. Calcium ions help clay particles aggregate into crumbs that create pore space for air and water movement. Compacted soil that sheds water begins absorbing rainfall as calcium-driven aggregation progresses. Magnesium content supports chlorophyll production once it cycles through soil biology into plant-available forms. The deep green color that returns to struggling plants reflects magnesium reaching leaves through biological pathways rather than synthetic application. Potassium, manganese, copper, and zinc round out the mineral contribution. Each element plays specific roles in plant metabolism and soil biology. The package arrives in molasses for approximately $2 per bottle rather than through multiple specialized fertilizer products costing far more. The mineral delivery through biological cycling is fundamentally different from synthetic fertilizer application. Chemical fertilizers deliver nutrients in salt forms that plants can absorb directly. The salts also draw water from soil organisms through osmosis, killing beneficial biology with each application. Molasses, minerals, enter soil biology first, becoming available to plants only after biological processing that preserves and feeds rather than destroys. There is an application method that maximizes molasses effectiveness for soil revival. The basic ratio is 1 tablespoon of blackstrap molasses per gallon of water. This concentration provides sufficient sugar to feed bacteria without creating anaerobic conditions that would favor harmful microorganisms. Higher concentrations are not better and can actually suppress the beneficial biology you are trying to encourage. Water quality matters for the mixture. Chlorinated tap water kills soil biology just as it kills bacteria in drinking water. Dechlorinating water before mixing is essential for full effectiveness. Simply filling containers and allowing them to sit uncovered for 24 hours allows chlorine to evaporate. Alternatively, adding a pinch of vitamin C powder neutralizes chlorine instantly. Application rate for severely depleted soil is 1 gallon of molasses water per 10 square feet of garden area. This rate can be applied weekly for the first month of soil revival. After biological activity establishes, monthly applications maintain the population and continue improvement. Timing of application affects results significantly. Soil microorganisms are most active when soil temperature exceeds 50 degrees Fahrenheit. Applications during cold weather produce minimal response because dormant bacteria cannot utilize the food source. Spring through fall provides the window for maximum effectiveness. Moisture must be present for biological activity. Applying molasses water to bone-dry soil wastes the amendment because bacteria cannot function without moisture. Watering before and after molasses application ensures the sugar reaches organisms capable of consuming it. Combination with other organic inputs accelerates results dramatically. Molasses water applied to fresh compost additions feeds bacteria that begin decomposing the organic matter immediately. The combination of carbon from compost and energy from molasses creates optimal conditions for rapid biological expansion. There is a comparison between molasses and synthetic fertilizers that the industry cannot allow gardeners to see. A bag of synthetic fertilizer costs between $15 and $40, depending on formulation and brand. The bag provides nutrients for perhaps 2 to 3 applications across a small garden. Annual spending for a typical suburban garden reaches $100 or more for synthetic inputs alone. A bottle of blackstrap molasses costs approximately $2 to $4 at any grocery store. The bottle provides dozens of applications at recommended rates. Annual spending for molasses-based soil building rarely exceeds $20, even for larger gardens. The cost comparison alone favors molasses by 5 to 1 or greater. But cost is the least important difference between the approaches. Synthetic fertilizers deplete soil biology with every application. The garden becomes more dependent on purchased inputs each season. Fertility must be purchased because the natural systems generating fertility have been destroyed. The business model depends on creating dependency. Molasses rebuilds soil biology with every application. The garden becomes less dependent on any inputs as natural fertility systems recover. Eventually, the soil generates sufficient fertility that even molasses becomes optional rather than necessary. The approach eliminates dependency rather than creating it. Synthetic fertilizers provide nutrients for one season only. The chemicals either get absorbed by plants, leach away in rainfall, or bind to soil particles in unavailable forms. Next season requires complete repurchase of inputs used the previous year. Molasses creates biological systems that persist and expand independently. The bacteria fed this season multiply and continue cycling nutrients next season without additional input. The worms that arrive this year reproduce and continue improving soil structure for decades. The investment compounds, rather than evaporating. Environmental impact diverges dramatically between approaches. Synthetic fertilizer production requires natural gas, mining operations, and industrial processing that generate significant carbon emissions. Runoff carries excess nutrients to waterways where they cause algal blooms and dead zones. The approach degrades ecosystems far beyond the garden being treated. Molasses is a waste product of sugar production that would otherwise require disposal. Using it in gardens diverts material from waste streams. The biological activity it supports sequesters carbon in soil rather than releasing it. The approach regenerates ecosystems rather than degrading them. There is an earthworm ecology that explains the remarkable 3-day response to molasses application. Earthworms do not materialize from nothing when conditions improve. They exist in soil continuously, but concentrate their activity where food sources are available. Deep soil layers contain worm populations surviving on minimal organic matter, even in the most depleted gardens. Surface applications of food trigger vertical migration toward the abundance. The chemical signals that worms follow are remarkably specific: bacterial metabolites, decomposing organic matter, and specific nutrient concentrations all guide worm movement through soil. The molasses application creates a chemical gradient that worms detect and follow from whatever depth they currently occupy. Migration speed depends on soil conditions and distance traveled. Worms can move several feet in a single day through loose soil with adequate moisture. The 3-day timeline for visible worm appearance reflects typical migration distance from survival depth to surface feeding zones. Population expansion follows the initial migration. Earthworms reproduce rapidly when food is abundant. A single worm can produce dozens of offspring in a season under optimal conditions. The hundreds that appear initially can become thousands within months, as reproduction compounds the original migration. The tunneling activity of earthworms provides benefits beyond their feeding. Each tunnel creates channels for water infiltration and root penetration. The castings deposited throughout the soil contain concentrated nutrients in plant-available forms. The mucus secreted on tunnel walls feeds bacterial populations that continue growing independent of additional molasses application. Long-term worm activity transforms soil structure completely. Compacted ground becomes porous. Hardpan layers get penetrated. Drainage improves while water retention in upper layers also improves as organic matter accumulates. The worms physically engineer soil conditions that support their own population while simultaneously creating ideal growing conditions for plants. There is an industry threat that explains why molasses remains virtually unknown among mainstream gardeners. The global fertilizer industry generates approximately $70 billion in annual revenue. This figure represents farmers and gardeners purchasing products every season because soil has been depleted of natural fertility. The business model depends entirely on continued depletion and continued purchasing. Molasses threatens this model at its foundation. Soil biology rebuilt through molasses. Application generates fertility without purchased inputs. Each garden converted to biological methods represents a customer permanently lost. Each gardener educated about soil biology becomes an advocate who converts others. The industry response has been strategic silence rather than direct opposition. Fertilizer companies do not publish studies attacking molasses because doing so would acknowledge its existence. They do not lobby against molasses sales because molasses is food rather than agricultural product. They simply ensure that their marketing reaches gardeners while information about alternatives does not. Agricultural extension services receive significant funding from fertilizer industry sources. The research priorities, educational materials, and recommendations that flow from these services reflect funding sources rather than optimal gardening practices. Molasses does not appear in extension recommendations because recommending it serves no funder's interests. Garden media depends on advertising revenue from fertilizer companies and garden product manufacturers. Editorial content that threatens advertiser revenue does not survive editorial review. Articles about molasses would reduce fertilizer sales that fund the publications. The articles do not get written. The information vacuum is artificial and deliberate. The science supporting molasses application is published in academic journals. The traditional knowledge predates industrial agriculture by centuries. The practical results are demonstrated in gardens worldwide. Only mainstream awareness is missing, and that absence is engineered. There is a traditional wisdom about molasses that predates industrial agriculture entirely. Organic farming pioneers in the early 20th century documented molasses application as standard practice. Sir Albert Howard, considered the father of organic agriculture, wrote about feeding soil biology rather than feeding plants directly. Molasses was among the materials he recommended for bacterial stimulation. Sugar applications to soil appear in agricultural literature from the 19th century and earlier. Farmers understood that sweet liquids improved soil condition even without understanding the biological mechanisms involved. Traditional knowledge accumulated through observation over generations. The mechanization and chemicalization of agriculture after World War II displaced this knowledge. Synthetic fertilizers promised convenience and consistency that traditional methods could not match in industrial-scale operations. The knowledge that sustained farming for millennia was dismissed as primitive within a single generation. Home gardeners inherited the industrial approach through extension services designed to disseminate commercial agriculture methods. The assumption that professional farmers know best transferred chemical dependency from farm fields to suburban gardens. The traditional knowledge that worked perfectly at garden scale was abandoned along with the industrial practices it never actually required. The rediscovery happening now represents traditional wisdom meeting modern biological science. The mechanisms that explain molasses effectiveness validate practices that farmers used intuitively for centuries. Science is not revealing something new. Science is explaining why something old actually worked. There is a fundamental choice available to every single gardener who has absorbed this information. Continue purchasing synthetic fertilizers that cost significantly more, actively degrade soil biology with every application, create measurable environmental damage through runoff and emissions, and require complete repurchase every single season indefinitely without ever improving underlying soil health. Continue supporting an industry that profits directly from your ignorance and engineered dependency. Continue gardening with methods that make next season harder and more expensive than this season. Or buy a $2 bottle of molasses from any grocery store and transform absolutely everything about how your garden functions. 1 tablespoon per gallon of dechlorinated water. 1 gallon per 10 square feet of garden area. 1 application per week until the worms arrive in visible numbers. Then watch with amazement as the biology that synthetic agriculture systematically destroyed over decades rebuilds itself naturally without any further intervention or purchased inputs. The worms appear within days. The soil structure improves within weeks. The plant health transforms within the growing season. The dependency on purchased inputs ends permanently as natural fertility systems resume function. The fertilizer industry has 70 billion reasons to keep this information obscure. They have succeeded for decades by controlling the channels through which gardening information flows. They have maintained ignorance by funding research, extension, and media that serves their interests rather than gardener interests. This video breaks their information control. The science is explained. The application is simple. The cost is negligible. The results are visible within days. Every gardener who tries molasses and sees the worms arrive becomes a witness that the industry cannot silence. One bottle from any grocery store, anywhere. 3 days until the worms appear. Soil that was dead becomes soil that lives. The $70 billion industry hopes this video stops here. The file is completely open now. The suppressed knowledge cannot be contained once enough gardeners share what they learn and witness with their own eyes. Subscribe now and hit the bell to see what other simple, powerful solutions are hidden while industries profit from complex products that work worse and cost more.